Okay, so this question 6 is about people wearing glasses or contact lenses or not. And I've now got to think about a sample of 40 men, and I've got to work out some probabilities here. And if you read through carefully and you're looking for trigger words to underline, there isn't anything that really gives away by one word what the method is. But so we have to think about what kind of situation we're in. We've got a fixed number of people here, 40 people. Okay, we're counting, because we're interested in whether it's at most 15, we're counting how many do not wear glasses or contact lenses. So we're counting how many have this characteristic in a fixed number of 40 people. So we're counting the number of successes in n independent trials. We have to assume that the people are independent of each other. So therefore, that's what triggers us to think, this is a question about a binomial distribution. So that's the way into the question. Sometimes you have to do the whole of the rest of the paper and you realize you haven't had the binomial distribution question yet. So first step here is to realize we're dealing with a binomial distribution. So x is going to have a binomial distribution. We need a value of n and a value of p. Okay, and then all we're going to do is use our binomial CD. You don't ever have to use binomial PD if you always do it the same way. So the possible outcomes are anything from 0 up to 40 people could be the number who don't wear glasses or contact lenses. But I'm interested particularly in values near 15. So we put 14, we put 15, we put 16, we put ... and we put ... and then you tick the ones that it could be and you put crosses on the ones that it couldn't be. Okay, and the ones that your calculator will allow you to work out directly are ones like the first one where we've got some values down here. We've got a cutoff point. We're interested in some number of values up to a particular point and then not after that. That's what your calculator looks up directly. So part 1 is a direct lookup from your calculator with the correct n and the correct p. This is the set of outcomes that are more than 10 but fewer than 20. Be careful with words like more and fewer. More than 10 means that 10 isn't allowed. Fewer than 20 means 20 isn't allowed. So once again, you do your list of outcomes, you put on your ticks and crosses, but this time we have to have a big box that includes all of the values we want and then take away the probability of a smaller box that removes all the values with crosses on. So the ones that are in here are the ones with ticks, these ones are crossed, and the ones past that point are crossed. So you're going to work out 2 binomial CDs and subtract your answers. And it's worthwhile showing your method. So you're doing the probability of x being less than or equal to one value, take away the probability of x being less than or equal to another value. Then in part B, we've got to calculate the probability that in a random sample of 10, so we're changing the value of n, exactly 3 do not wear glasses or contact lenses. Once again, we've got an n value, we've got a p value. Okay, we draw a diagram of the outcomes, and we do something similar to what we were doing in A to find the probability of that individual outcome. You may remember that binomial PD is for this case, so you can choose to use it if you like, but be really careful, because if you leave your calculator in that mode, then all of the ones you do for binomial CD will be wrong. Then part C, we've got to calculate the mean and variance. So the mean and variance, we're still working with a binomial distribution, though you've got to read this carefully. So we now do wear glasses, so that's going to, or contact lenses, so that's going to change the probability. So we've got a new value of P, we've got a new value of N. But if I know N and P, then I can work out mean and variance. These formulas are on page, page 13, or is it page 11? Page 11, isn't it? Page 11 of your formula book has got these formulas. Okay. This is the table you need from page 11 of the formula book. And as always, when working out a variance or a standard deviation, you actually just double check and make sure that any squaring or square rooting that you should do, you do, but if you shouldn't do it, then make sure you don't do it. And then in part 2, we've got the numbers wearing glasses or contact lenses in 10 groups. We've got the mean and the variance of those 10 10 groups. In other words, we've taken a sample. We've looked at 10 possibilities, and we worked out this mean and this variance, and we've got a theoretical mean and variance here. We've got an observed mean and a variance, and then we've got to comment on a claim. So, if the 10 groups were random samples, then all the conditions for binomial distributions will have been met, and the mean and variance should be what you are calculating here. Okay, if these values are hugely different from that, then therefore that assumption was probably wrong. But if the values are roughly the same, then the assumption may well have been correct. So that's how you deal with this. So there are 3 marks for this. So you're going to get some of the marks just by commenting on the particular values. So you've got values to the mean, you've got values to the variance. So make sure you comment on each of those. And then at the end, you give a verdict on the claim. You either say this claim is probably invalid, or you say this claim could well be valid.